The first column shows the current, the times using the current procedure, the xi, and also this is the times using the new procedure, which is yi. So we have DI, which is subtracting 66.4 and 70. So we have minus sign here. So the difference will be some is positive, some is negative. And then we need to take the absolute value of it. So absolute value of minus 3.6 is 3.6. So we have all this absolute value of the difference, and then we need to rank this absolute value. So before we rank the absolute value, we need to take out the observation that has zero difference. So the second uh, observation, the difference is zero, so this is taken out from the calculation. So how do we rank? So the lowest is 1.7, so it gets rank 1, and then 3.6 we have two values, 3.6, 3.6. So it will take the rank of 2 and 3. So the average of 2 and 3 is 2 plus 3 divided by 2, which is 2.5. So they are sharing the rank 2.5 and also 2.5 here. And then since we already used rank 2 and rank 3, so the next is going to be the fourth rank. So this is 5.7 is the fourth rank, the fifth, the sixth. So even though we have 7 observation, we just have 6 rank because the second observation we omit from the calculation because the difference is 0. So what is the test statistic? The statistic is T equals to summation of T plus. So T plus here means it is the rank for the positive difference. So from all the ranks, we are choosing the ranks that has the positive difference only. So this is the difference. It has a positive difference and also a negative difference. But then we just choose the positive difference. So meaning this one is already omitted. So meaning we're going to choose this one, this observation, this observation, this observation, and also this observation. So only 4 of the observations are chosen because the difference is positive. So for each of these observation, the rank is 6, 5, 4, and 2.5. So we are not choosing this one because it is a negative difference. We are not choosing this one, yeah, because the difference is 0. And we are not choosing this rank because it is from the negative difference. So only 4 observation involved. So we add up all these T plus. So 6 plus 5 plus 4 plus 2.5 is 17.5. So since we want to test the claim whether the new procedure or new method is an improvement over the current procedure used, so meaning that H null MD, the difference is equals to 0, H1 MD is larger than 0 because since it is an improvement, meaning that the difference should be large. So we are saying that MD is a positive larger than 0. Alpha, suppose you choose 5%. So this T again, the statistic is 17.5. And then we need to look at the critical value. So critical value here, our N is going to be 6. Alpha is 0.05 and it is a one-tailed test. So we need to look at the table. For this test, we are using table 10, listing down TL and TU critical values, whereby we need to have alpha and also N. And here is the number of observations whereby DI is not equals to 0. So going back to DI, this is the list of the difference. So we have one of the observation, the difference is 0. Total sample is 7. So since 1 is equals to 0, others are not equals to 0. So our N here will be 6. So 7 minus 1 of the observation is difference 0. So it is left with 6. 6 observation that has difference not equals to 0. From table 10, critical values for the Wilcoxon sign rank sum test, alpha 0.05 and is a one-tailed test. So referring to n equals to 6, the TL is 2 and the TU is 19. So this is the critical value. So going back to this table, so for our example, it is a one-tailed test whereby our MD is larger than 0. So when do we reject H null? When T is larger than TU. So from the TU and TL that we get from the critical value table, we just going to refer to TU. TU is 19. So our test statistic is 17.5. So test statistic is less than the critical value. So meaning that do not reject H null or we fail to reject H null. So the conclusion, there is not enough evidence to conclude that the new method could be an improvement over the one currently used.